Now, we unit test Python, we unit test pipelines, but SQL notebooks, mostly don't test them at all. And considering how much logic we put into SQL, that's pretty big blind spot, I would say. And that isn't some edge case language as well. R or Scala, it might take maybe something like 5% of all of the notebooks that I'm aware at least. But Python and SQL are the first-class citizens, and in Microsoft Fabric, SQL it's very used language, and you have SQL notebooks, you have your SQL endpoints where you can write queries to test things, and SQL-based transformations, and real production logic lives there. So treating SQL as just queries instead of production code doesn't really make sense anymore. So in this video, I'm not going to show classic unit tests for SQL. Instead, I'll show you how to use contract tests. And that is because SQL notebooks, for me at least, it is usually the right mental model. Here is a key difference between contract tests and unit tests. Unit tests are great when you have behavior. So functions with different inputs and outputs where you can test edge cases. But SQL notebooks, they usually aren't about behavior, and they're about guarantees and promises. You test things like what columns exist, what data types they are, and which columns can or cannot be null, and what kind of transformation rules must hold true. Downstream systems don't really care how your SQL produced the data, they care about the contract that is respected. And contract testing is about verifying that your data meets an agreed upon shape and rules, and not the implementation details. So instead of forcing SQL into a unit testing model that doesn't really fit, contract tests let us lock down the expectations a way that was simpler, more robust, and potentially a little bit faster as well, because you don't need to run the SQL commands somewhere, so you don't need an interpreter for them. And this is especially important in data platforms, where breaking the contract usually hurts someone else first, and not necessarily whoever maintaining the system. Let me show you how this works in practice. Imagine that you have this notebook that is used to set up your views, and those views are going to be used, for example, between the silver and gold. So some sort of business logic transformation would be in there, and you want to test the contract, as I said, that the thing is all good. Important consideration right now is that I'm using T-SQL dialect of the whole thing, and if you would write using, say, Spark SQL or Spark SQL and use a different language, then you would need to change the dialect that is going to be used later on. But let's get back to the code, and what I have in terms of the view itself and the notebook structure is that first, just some pretty random, make sure that you are using the Lakehouse Silver Lakehouse that actually linked over here and is used by default. But anyways, there is go command as well, and after that I create or alter view invalid customers, where I just check that the postal code is not null. Sorry, if it is null, then I create a category, then I create a view with invalid customers, and in parallel in a different cell I create a view with valid customer, and I just double check that the postal code is greater than 7000 for no reason at all. Then I change how we treat the category. Maybe it would be used for the drop-down selection in reports or something else, but basically I want to treat the novelty shop as 1 and everything else as 0. So some sort of logic is present. And after that some magic numbers, so valid 2 minus current date, so how many valid years are still for this customer for some reason. Honestly speaking, I haven't really dive into the data itself. But afterwards we can run the select top 10 from views customers and see some results. So tailspin toys from different locations, They all of the category 1 no zeros, and valid years are all the same because most of them they are actually coming from the same 2013 if I'm not mistaken. So we can just double check actually. And we can see that in the customers, the initial table, we have some customer key, we have other keys, we have actual customers, and the data like valid from is from 2013, valid to is 49s, so forever, and so on. Now we want to have a contract test for this notebook. We can commit those changes into the Git as usual and get it from the Visual Studio, the content of the notebook. In case of SQL notebooks, that would be in the notebook content.sql file already, so not the Python file like it was for Python notebooks. What we can see as well in the notebook itself is that there are a lot of comments with some metadata similar to Python to split between cells. So cell 1 is used like how Silva, and then cell 2 is create a invalid customers views, and so on. And my last cell is just some sort of a testing one. What I suggest that we use, and that's one of approaches that is possible, is that we are going to use SQL glot to parse this SQL code and then verify the contract for this one. The contract itself is written in the contract.yaml file, and as you can see, it just verifies a single view at the moment, so everything under the one big root directory. And if you would want to split and have contracts for different views under the same file, you would need to change that structure a little bit, but as it goes, it will verify everything from this file. What I'm doing is I have split the code into separate functions, and only the last one, the validate contract, actually doing the whole thing. So what we are trying to do, we are parsing the SQL using SQL glot, but it will not work out of the blue without some additional magic, because we need to clean the Fabric SQL. More importantly, we need to clean up all of the comments and clean up the go command, because SQL glot cannot really understand the difference between them. After that, each of the commands, each of the statements that we have, so select top 10 star and use like how Silva and create alt view, those would be treated as separate SQL trees, and we would need to iterate through them one by one. What it means is that we are going to find the correct tree, the tree view, based on the name of it, and that's what we have here. When we validate in the contract, we parse the whole SQL, then we find the one tree that we are interested in, and then we verify the expressions. More importantly, we check them from the columns view. For example, the customers column, the customers view customers needs to have a customer column, and it is required. Also, we want to have a category type column, and that column should have an expression containing the case category. So we are checking that this logic is present. Not necessarily one-to-one, and it's just a pretty much a regex match, but still it is enough for the contract validation. And after that, we can run the PyTest SQL test, and it will good, and we will have a green test that one is passed. If we change that we don't want to have case category, but it wants instead case name for some reason, then the fail is expected, and we would be able to find and catch those issues pretty early in the development phase. So before we go to QA environment, we supposedly will run this test as part of the CI/CD pipeline, and it will fail and won't allow us to go any further, which is the whole idea of unit testing or the contract testing in that case. I hope you learned something from this video. So stay tuned for more videos. Bye.